What is going on, guys? Welcome back. In today's video, we're going to compare the speed of Python with the speed of other programming languages in terms of execution speed and development speed, and the results might actually surprise you. So let us get right into it.
It's not a game, it's a rich thing.
Now, before we get to the actual video, I would like to mention that this video is sponsored by Bixly. And don't skip this part because this could be quite interesting to some of you guys working on software projects. Oftentimes, software projects are quite difficult to finish, and Bixly can help you with that. They have been successfully completing projects on time and on budget since the year 2008, so they have a solid track record of successful completion with the money they have, with the time they have. And they offer multiple different services. You can go to their website. You will find a link in the description down below, bixly.com/nn for Neural 9. And you can click on their services tab, for example, to see what they offer here. They have different services like no or low code type of services, enterprise development, DevOps, mobile development, and more. You can take a look at that. And if you need some help getting your project finished on time or getting it done right the first time, you can talk to the people at Bixly.com. As I mentioned, you will find a link in the description down below, and they have a solid track record. And in addition to that, you can also get a free consultation by visiting their website on the link in the description down below. Alright, so what we're going to do in this video today is going to be quite simple. We're going to measure execution times of different programs, or basically of the same programs written in different languages, and we're going to compare the speed of the different programming languages. We're going to do that in two parts. The first part is a very, very simple program written in 6 different programming languages, and the second part is a more complex program written in 3 different programming languages, and we're going to compare the execution speed here. So the first program is going to be quite simple. I'm going to create a new Python file here. I'm going to call it main.py, and I'm going to basically just say that I have a variable mySum equals 0, and all I'm going to do is I'm going to say for I in range, and I'm going to pick a very large number. To be precise, this is 123, 0, so this is 100 million. So 100, 123, 123. This is the number that we're going to have as the maximum, and what we're going to do with the control variable I is we're going to add it to the sum. So we're going to say mySum plus equals I. And that's all we want to do here. We want to iterate from 0 to this number here, and we want to add all the numbers, all the values to mySum, and that's our script. And we're going to do the same thing now in C. We're going to do it in Go, we're going to do it in Java, we're going to do it in JavaScript, and we're going to do it in R. And then we're going to compare the run times, the execution times for the same task here. So this is the Python implementation. And one thing that you can also keep in the back of your mind while we're doing this is how long it takes to implement it, because there are 2 different types of speeds when it comes to a programming language. It's the execution speed, but it's also the development speed. So how fast can I come up with a solution? How fast can I write a solution in Python code, in C code, in Java code? And in Python, this is quite simple. I just define a variable, I iterate, and I add to that variable. That's all we need to do here. Now let's go ahead and do the same thing in C. So I'm going to do it in PyCharm here as well. You can use the editor of your choice. I'm going to just say new file, main.c. I'm going to zoom in, and I'm going to just say include stdioh. I'm going to say int main, and I'm going to say now that we have a long sum is going to be equal to 0. And then for int I starting at 0, I being less than 100 million. So 123, 123, I plus plus. All we're going to do here is we're going to say sum plus equals I. And then we're going to return 0 to get out of the script or out of the program. That is our C implementation. It isn't much longer than the Python implementation. We need to have a main function and we need to include something, but basically it's also not too difficult to write it, especially because this is quite a simple program. If we have something more complex, the development time in C is going to be way more than that of Python. Now let's go ahead and do the Java implementation, main.java. And for this, we're going to just say here public, or actually public class main. Inside of that public class, we're going to have a public static void main taking string array arguments without the exception, please. And then we're going to just say here that we have a long sum being equal to 0. And we're going to say again for int I equals 0, I being less than, or let's say less or equal to 100, 123, 123, I plus plus. Actually, I think we should keep less than. Then we're going to say here sum plus equals I as well. And then in the end, we're going to just, actually, we don't want to print the sum. We're just going to keep it like that. That is the Java implementation. Now let's go ahead and create another one. We're going to do a Go implementation main.go. For that, let me just see what I prepared here. We're going to say package main. We're going to say import format, so FMT. We're going to say function main. And we're going to say that the sum is being defined here as 0. We're going to say for I being defined as 0, I being less than 100 million, I plus plus, and then sum plus equals I, and we don't want to print it, so we're going to leave it at that. And then we need two more implementations, the JavaScript implementation. So we're going to say main.js. We're going to say here, let sum be equal to 0 for let I equal 0, I less than 100, 123, 123 million, I plus plus. You can see the syntax is quite simple for all these languages. Not quite simple, quite similar is what I wanted to say. Sum plus equals I. And then that's basically it in JavaScript. And finally, let's do the R implementation as well, main.r. And for this, all we need to do is we need to say that the sum is equal to 0 for I in 0 up until 100 million. The sum is going to be equal to sum plus I. And we don't want to print anything. So that's it. Those are the 6 implementations now, and we can run them. Of course, you need to have all these runtimes installed. You don't have to do it if you don't want to reproduce everything in this video. You can just watch and look at the results. What I'm going to do now to time all of this is I'm going to open up my Windows terminal here, and in particular, I'm going to open up the subsystem for Linux, so the Ubuntu terminal. And what I'm going to do now is I'm going to navigate to this directory. So in my case, this is this one. I'm going to zoom in a little bit. I'm going to maximize this. And what I'm going to do here now is I'm going to run all these scripts with a time command. So for example, to run the C program, what we need to do is we need to first compile it. So we can see here with ls, those are all these files, and they have to be run in a different way. And of course, you need to have all these things installed. So you need to have the GCC compiler to compile the C file. You need to have Go to run Go. But for example, to run Go, what I can do is I can say Go run and then main.go. That's all I need to do. Package command line arguments is not a main package. Let me just see what the problem could be here. Mainers. Why did I provide mainers? Main was the package I wanted to use. Let's run this again. Imported and not used FMT. Okay, we don't need it if we don't want to print anything. That's actually correct. So let's go ahead and do it again. There you go. So this ran. Of course, we don't print the result because the printing would also take some time. We want to keep it without any output. If you want to make sure that you're actually getting the sum, you could just print in the end, in this case with format, in other languages with print line and stuff like that. You can print the output to make sure you get the same result, but actually for timing the execution speed, I don't want to have the result. And to see how long this actually takes now, all I need to do is I need to say time go run main.go. And I get exactly how much time this took. And this, in this case, took 0.156 seconds for the Go program to execute. We can do the same now for, I think for JavaScript, we need to say node main.js. There you go. So we can time this as well. Node main.js. You can see 0.192 seconds. Now let's go ahead and run the Java script, so main dot, or not the JavaScript, the Java program. So main Java, and let's time this. This takes a little bit longer, twice as long as the Go implementation, so 0.327 seconds. now we also have R. For R, we need to run R script. So time R script main.r. This takes a bit longer, 1.38 seconds. Now let's go ahead and compile the C program. So gcc main.c output is main.out, and then just main.out. And we can time this, and you can see this one is super fast, 0.069. This is the fastest. And now we're all curious about the Python result. Let's go ahead, time python3 main.py. And you can see this takes quite some time. I don't know exactly how long, in this case 4.69 seconds. I thought it might run for 18 seconds or something. But you can see that this is a huge difference. Python is way slower than all these other languages, even than R. And we can actually go ahead, for example, into the Go script and actually append another 0. And I think it should be still faster, even though it's processing way more values. It should be faster than the Python implementation. So if I time now the Go again, prove me wrong. No, there you go, 0.37 seconds, way faster, even though it had an additional 0, way faster than the Python implementation. So what you want to think about is how much faster are other languages when it comes to execution speed, and how much faster is Python in terms of development speed? Because this is a very, very concise code, 3 lines, very simple. You can also turn this into a list comprehension, making it more effective. But then the other thing is, of course, when you have some more complex stuff, when you have big projects with big algorithms, with large algorithms, it's going to get more and more complex, especially in languages like C. You're going to have a lot of stuff around the logic that you don't need in Python, that Python does automatically for you. So the development speed is more important in those cases than the execution speed. But also I want to show you the other example. We're going to get to that here in a second, where we're going to see that Python isn't actually necessarily slower depending on how you use it. And for this, we're going to do something a bit more complicated. We're going to program matrix multiplication in Python, in Java, and in C, and we're going to compare those languages in terms of runtime, so in terms of execution speed, but also in terms of development speed. And we're going to start here with the C implementation. So I'm going to create a new file here, matrix.c. And by the way, before anyone gets upset, the example and part of the code is inspired by a Medium blog post that I found. So I didn't copy paste anything, but the structure might be quite similar because this was a good example. So I don't want to take full credit for it. But what we're going to do here is we're going to say include stdio.h. We're going to also include the stdlib. And we're going to define a main function. And before we do that, we're going to define matrices up here. So we're going to say double matrix A of size 500, 500. And I want to do the same thing for B and C. And what I want to do now is I want to say for int I equals 0. And I'm not going to go into the details of matrix multiplication here, how it works, what we do exactly, because first of all, I have a video on it. And second of all, the focus is on the speed comparison. So we're going to say here, I being less than 500, we're going to iterate over the different columns and rows. So inside of that loop, we're going to have another loop, int j equals 0, j being also less than 500, j plus plus. And inside of here, we're going to say aij is going to be, we're going to typecast here double a random number. So we're going to just initialize these two arrays randomly, A and B. And we're going to initialize C with zeros. So ij is going to be 0, all values. And then we're going to perform the actual multiplication. So this is just the random initialization. And then we're going to say now for int I, actually let me copy this because the structure is going to be the same. For int I in j up until 500. We're going to close this here. And inside what we're going to do is we're going to do another thing. We're going to say for k, or for int k being equal to 0, k being less than 500 as well, k plus plus. And we're going to do the following. We're going to define the multiplication as Cij is going to be plus equal A I k times b k j. That's just this typical matrix multiplication where you take the column and the row of the individual matrices to calculate a certain field in the resulting matrix. Again, I'm not going to go into the mathematical explanation here, but this is basically how you do it in C. So we can return 0 here, and that is the C implementation. Let me just briefly see if it works. So let's go ahead and compile it, matrix.c out matrix.out. No, we have a problem. We forgot the semicolon here. Let's do it again. We have another problem. What is that? Did I forget the semicolon here as well? Of course I did. Now it works. Slash matrix dot out. There you go. It executed at least. So that's the C implementation. Let's do the same thing in Java now. So let's say main, or actually not main, matrix.java. And for that, what we're going to do here, first of all, is we're going to import Java util random to generate some random numbers. We're going to say public class matrix multiplication. We're going to define a static double multidimensional array A, which is going to be a new double multidimensional array of size 500, 500. We're going to do the same thing here for B and C. And then we're going to say public static void main string array arguments. And then we're going to say that we want to generate a randomizer, so a random number generator. And we're going to say for int I equals 0, I being less than 500, I plus plus, for int j being equal to 0, j being less than 500, j plus plus. And then here we're going to say now again, ij is going to be equal to r dot next double. For B, the same thing. And for C, we're going to just assign 0 again. That's that. And we need to do the actual multiplication here. So I'm going to just copy from the C file because this is actually the same in Java. Actually, I think you can use all of it. So this should be exactly the same in Java, right? So we can just copy it. What's wrong with the indentation here? Is there a problem? This should be indented. This should be indented. This should be indented. And then we have this, we have this, we have this. What is that? Do we have... Let me just reformat the code here. Okay. I don't know if that... No, we need one more. For the function and for the class. But since this is not a Java IDE, it probably doesn't recognize that. So let's just see if that works as well. Java matrix.java. That seems to work without getting any problems. And now we're going to do the same thing in Python. Now, in terms of development speed, this is going to be a bit faster. So we're going to say matrix.py. We're going to import random. Let me just zoom in here. And we're going to say now A is equal. And we're going to do a list comprehension right away. So we're going to say here random.random is what we're going to have here as an initializer. And we're going to say for some variable that we don't need to name in range 500. And this list will be produced again for something that we don't need to name in range 500. So we have a 500 times 500 matrix. We're going to do the same thing for B. And for C, we're going to do 0. And then all we need to do is we need to say for I in range 500. For j in range 500, for k in range 500, c I j plus equals a I k times b k j. And we can go into the command line here, Python 3 matrix.py, and this probably will take quite a bit longer. As you can see here, we're going to time it here in a second. Actually, let me just interrupt to do the timing right away. So we're going to time here matrix.out, which is the C implementation. This is done in 0.347 seconds. I can time now the Java matrix.java implementation, 0.68 seconds, so twice as long as the C implementation. And now the Python implementation, matrix.py, you're going to see that this is going to be significantly slower. But the results, as I said, might surprise you, because we're going to see that Python is actually quite fast if we do things differently. And I'm going to show you here how that works in a second. I think this should take around 18 or 20 seconds. It takes quite some time. There you go, 18.8 seconds for this same task to be accomplished in Python. This is a huge difference here, but I'm going to show you now that this does not have to be the case. I'm going to open up a new Python file here, matrix, let's call it optimized.py, and this is going to be quite impressive, because this is going to be the best solution in terms of development speed, and I'm not sure if it's going to be the best one in terms of execution speed, but it's going to be very fast. All we need to do is we need to say import numpy as np, and we're going to say a equals np.random.random of shape 500, 500. This basically creates a randomized 500 times 500 numpy array. We're going to do the same thing with b, and all we need to do now to perform the matrix multiplication, I have a video on that already, is we need to say a at b. So C is equal to A at B, and that's the code. This is the best development speed solution that we have. It's super clear, super concise. And we're going to go into the terminal now, and we're going to say time Python 3 matrix optimized. And you can see that this is actually faster than the C solution. And the reason for that is, those of you who have worked with Python for quite some time probably know this already. NumPy is written in C. Python itself, the C Python implementation, the most common implementation, is written in C. And modules like NumPy, Pandas, scikit-learn are actually written in optimized C. So what we're doing here is we're just giving the instructions, we're writing the instructions in Python code with the simplicity and the flexibility of Python. But what is actually happening behind the scenes in NumPy is executing C code and executing optimized C code. So here we create two arrays with the size here, and we just do the matrix multiplication, and it's way faster than in C or in Java, just because this is optimized C. So it's basically running C, running optimized C, and we still have the best development speed. So you can see Python does not have to be the worst choice when it comes to efficiency. It all depends on what you're doing. So if you're implementing stuff from scratch, if you're writing machine learning algorithms from scratch in core Python, that's probably a terrible idea, because you should not be doing that. You should work with NumPy, with Pandas, or if you want to do something from scratch, do it in C, C++, and use it in Python. So Python is the best language that we saw today in terms of development speed and simplicity of code. But it's not the best language when it comes to writing the core, the code in core Python. But this problem with the efficiency can be solved by just using efficient code, efficient C implementations with the flexibility and the simplicity of Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, thanks to Bixly for sponsoring this video. Check them out at the link in the description down below. Besides that, don't forget to subscribe and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.